Good morning everyone to the trainings of Open Mode project. This is session 6 where we are going to speak about the safety in a raft. Welcome. I am going to divide this talk in 4 main points. The first is the maritime safety. The second, we are going to speak about the potential collapse of a raft. The third, we will speak about the safety using a raft, the potential risks. And finally, we will speak about the potential measures, preventive or corrective, regarding the safety using a raft. Well, first of all, we are going to speak about the maritime safety. Well, as you can imagine, a raft, even if it's made of wood or Formex, even if it's big or small, is a floating element that can have an interaction with a boat or a ferry. So, first of all, the most relevant is that we obtain the license in an area where there is not a relevant interaction with possible maritime trafficking routes. An example of this is the picture that you can see, the location where we obtained the license to install the Tester 3 in Croatia. We have installed it in the Novigrad Sea because it has very good conditions to harvest shellfish, but also there are not significant maritime trafficking routes crossing the region. At the same time, it's relevant because in the end there is always the possibility to suffer an impact or an incident. It is relevant that we install a beaconing, which depends on the competent authority that manages in the region. In this case, you can see one of these beacons. We have 4 of them in the 4 corners just to indicate that there is a floating artifact. In Galicia region, there is a certain exemption from this because there are polygons where we have 100, 200, 400 floating farms all together, so it is not done yet, but the goal at long term is that the beaconing is done perimetrally to indicate the whole polygon and not the structures one by one. Well, the second point I would like to mention regarding the safety in a raft is its potential collapse. Normally the rafts, most of the experience regarding the collapse of rafts, all the experience is related with wooden rafts because they represent more than 90% of the rafts. And the most typical collapse or failure modes are here indicated. First is the breakage of the mooring beam. Normally, this kind of failure happens under significant storms, autumn or winter storms that cause significant height waves that imply a relevant punctual force in the mooring. And this force in some cases breaks or the chain or the mooring beams. So in the end, the problem is that the raft is adrift. It is not broken itself, but it is adrift and it can impact against a boat, impact against another floating structure, or go to the coast, as you can see in the figure that you have below in the right side. The second typical collapse mode is the breakage of the connection between the floater and the primary beam. This is normally because the steel bolts that connect the primary beam to the floater or they break or they are progressively unscrewed with the fatigue caused by the waves. You can see this effect in the figure below in the left side, how in some cases the floaters finally separate from the wooden structure. So in the end the raft has no more integrity and its parts are also adrift. And the third failure mode, well, it's not a failure mode, but it is in the end the collapse of a raft, is when the mooring is not heavy enough and it slips. So the raft can also get adrift or can also change its position and there is a potential collapse against other structures, or it can go to the coast or to another location. In general, these problems are associated to wood and it's much less possible that it happens in a Formex raft. And the reason is that in the case of a wooden raft, the beams have a different mechanical properties one from the other. Even if they have the same section, the mechanical properties are different because the trees of each log are different. There is a natural variability. This is something that doesn't happen in the Formex raft. So it is less common that under a storm there is a weak part in a beam or in a section or in an element compared to the wooden structure. In the case of the slipping of the mooring, it is similarly possible in a wooden raft or in a Formex raft that this happens because in the end this should be prevented with a conservative design of the mooring of the structure. So sometimes we need a 30-ton mooring instead of a 20-ton concrete block. So this is the way to avoid this last type of failure. Which are the potential risks of a farmer using a raft? Well, in the case of having wooden joists, which is something we have in the wooden rafts and also in some Formex rafts, one of the potential problems is the brittle failure of a joist. It can be more common in a wooden raft simply because when we nail a joist to a Formex raft, it is more stable than if we nail it to a wooden raft, because a wooden beam can be more irregular, or the nail can simply get out easier. The brittle failure of a joist can be caused because the wood quality is low, or simply because we don't maintain the joist adequately, we don't take care of it, and after some years, well, it gets rotten, and suddenly when we are walking on it, it suffers a brittle failure. It is not very common, but it can happen, and it is quite risky because the farmer can suffer a knock in the chest and then can go to the water without the ability to breathe adequately. So it's a significant risk that should be considered when we are using this kind of structures. Well, another relevant risk is that the farmer slips in the primary, secondary beam or in the joist. This slipping possibility is higher when the structure is not adequately maintained, because with the moisture and with the time, there is a certain type of algae that appears on the surface of the structure. This algae is called verdin. It can also be salt in some situations, as you can see in the right picture. And this verdin can appear both in the wooden rafts and in the Formex rafts. What is the difference? As the wood is organic, this algae get stuck stronger to the wooden raft than in the case of the Formex raft, because in the Formex raft, as it is inorganic, it is really easy to remove this algae from the structure. So normally the way to avoid this risk is simply to clean frequently the surface of the raft, or with water with pressure, or simply brushing the surface which we are going to use to walk. Well, and the last significant risk is the irregular transit area or corridors. In the end, to use a raft, what we need to have is a certain number of safe corridors that we use to walk on the structure and have access to the ropes. If the raft is not adequately maintained, these corridors are irregular or do not exist appropriately, and the farmer trying to use them can fall down. For example, in the two pictures in the right, you can see broken beams that are broken or damaged or have a difficult geometry to be used safely by a farmer. In the left side, you can see the picture of a Formex raft, how the beams are absolutely straight. They do not suffer a strain, a progressive deformation with the time. So it is a much safer and more secure structure to walk and to have access to the ropes. Well, besides of the maintenance of the beams and joists that should be applied to avoid the previous risks, what other measures and technologies can we use to make a safer raft? Well, the first is to avoid using an organic material as the wood, because it degrades faster and it has a natural variability, and we can start using an inorganic material in the raft. In our case, Formex is the name of this material, but maybe there are also other technologies in the future that could be used. The second point, well, there are different technologies that could be used to make a safer use of the raft. For example, we have installed in some of our structures an inclinometer. This inclinometer provides remote data about the maximum or minimum slope of the raft every day. So the farmer, before going to the structure, he already knows how agitated is the sea and if it is interesting to go there or not to go there. We can install also a GPS alert that sends us a message, for example, if the raft goes adrift, if it is in a region that it is not supposed to be, if it is adequately moored. This is an alerta that will tell us that the raft has gone adrift. Another technology that we can use are the 360 degrees cameras that we have installed also in some of our raft that simply show remotely, without the necessity to go to the raft, how is the condition of the raft, if there is some beam broken, or if there is a significant deformation, or if there is a storm that is going to break the mooring beam, or if we can detect some relevant damage through the camera. This is a complementary tools that can simply give more security to the farmer to know that things are good and to carry out preventive measures on time. Well, that is everything for session 6 of the trainings of Open Mode project. Thank you very much. I hope we can meet again in session 7. Thank you.